In a new study conducted on old data from the Rosetta mission, scientists have discovered evidence that Comet 67P actually has its own aurora. Let's examine this evidence and see how this might actually once more provide solid evidence of comets' electrical nature. The Rosetta mission was the first mission by ESA to send a probe to a comet and then land on the comet. The probe arrived in August 2014. It then orbited the comet, and on the 12th of November 2014, the Rosetta lander finally touched down on the surface. The mission finally ended on the 30th of September 2016 when they descended the whole probe onto the surface. We have previously looked at some of the images from the Rosetta mission and shown that the classic idea of these being icy bodies is false. The images show what looks more like an asteroid with a rocky surface. The mainstream explanation for these objects is that they are left over from the initial formation of the solar system and contain largely ice and dust. When they approach the Sun, this ice starts to melt, creating a vapor trail that we see as the comet's tail. The electric universe concept is that comets are nothing more than asteroids which have a different potential to their surroundings. The objects spend most of the times at the extreme edge of the solar system, which has a different charge potential to the inner part. When they approach the Sun, a charge imbalance develops between the nucleus and the higher voltage and charge density near the Sun. As the electrical stresses start to grow, discharge takes place and a plasma sheath develops which appears as the coma and the tail. The observed jets are the electric arc discharges which will cause electrical machining on the surface of the comet. This excavated material is accelerated along the jets into space. So what have the scientists found in the old data from the Rosetta mission? By digging into the data from numerous instruments on Rosetta and linking them together, they were able to see that there was a glow around the whole comet. They could also tell from the comparison of the data that this glow was auroral in nature. They had previously seen this glow but had attributed it to what they termed day glow, and this occurs when solar light interacts with the cometary gas, causing a glow. When they examined the data across various instruments, they were able to show that this glow was also occurring in shadowed parts of the comet, meaning it could not be caused by day glow. The mainstream explanation for the aurora is that charged particles from the Sun hit the Earth and flow along the magnetic field lines, and these will collide with oxygen and nitrogen in the atmosphere and impart energy to their electrons. When the electrons eventually release this energy, they do so as light at very specific frequencies. Christian Birkeland spent many years studying this phenomena. I've covered some of the work of Hannes Alvan, who built on this initial work by Christian Birkeland. If we examine his work on the auroral circuit, we can see a different perspective on this. We know that at the dawn side of the auroral circuit there are currents flowing into the auroral zone at high latitudes and leaving the zone at lower latitudes. At the evening side, these currents reverse. These currents flow in sheets along the magnetic field lines and are what we call Birkeland currents. The circuit is closed in the upper ionosphere and in the plasma near the equatorial plane. Spacecraft passing over these do indeed measure a voltage inversion. As these Birkeland currents sweep in and back out at the poles, a double layer is formed, and this causes electrons to stream downwards. Most of the energy from these electrons is dissipated in the ionosphere, where they cause the excitation of oxygen and nitrogen atoms, which creates the aurora. So is this really what is going on in this comet? Well, they concede that the comet cannot have a magnetic field, so instead they have to invoke an electric field. Yes, you heard me correctly. They think that the comet must have a very weak electric field due to plasma. They then think that this very weak electric field is somehow able to accelerate the electrons in the solar wind enough to cause them to collide with the plasma surrounding the comet, and that it is this interaction that causes the glow. What is interesting is the fact that they even assign this a positive charge. If we assume it is a ball of ice, how did it become ionized, and where did the electrons go? Why do the local electrons in space not simply neutralize them? Even stranger is if we do consider the electric field which surrounds this comet Now, I failed to see how this could cause the electrons coming from the solar wind to reach the opposite side. If for a moment we consider that these comets are in fact rocky bodies with a different overall charge potential to the Sun, the plasma surrounding the comet will form a plasma sheath. When the comet moves closer to the Sun, this plasma sheath grows and will start to glow, forming what we see as the coma and the tail surrounding the comet. Equally, when the comet is further away, the difference in potential will decrease, causing the sheath to shrink. At the same time, this will also cause the glow to reduce to a much fainter glow. Most importantly is that this glow occurs all around the comet, exactly like in a discharge tube or when we look at the discharge in sapphire. So inadvertently, and in a rather convoluted way, this paper once more confirms the electric nature of comets. As always, be brave, be curious, the truth is waiting for us. Until next time.